All right, like I said, this one is very similar, almost identical, just different numbers to example 7. Okay, but it's good to get practice. So here we have a normal random variable with a mean of 72 and a standard deviation of 12. Okay, so we want to know what's the probability that of this random variable being less than 50. So let's convert the 50 to a z-score. So we're going to take 50 minus 72, right? And divide it by the standard deviation, which is 12. All right. Now it's going to be negative, which makes sense because it's below the mean. So it's negative 1.83. It's a good thing to always check yourself. It's easy to switch these two numbers around, the 50 and the 72. But make sure it makes sense. 50 is below the mean. The mean is 72. So it makes sense that it should be negative. And then we're just going to look for the probability that z is less than a negative 1.83 in our table. So just look it up and we get 0.0336. All right, so 3.36%. And the next one, we're looking for the probability that the random variable is greater than 84. Okay, so but again, we're just going to start by calculating the z-score. So 84 minus 72 all over 12. We're expecting it to be positive because 84 is greater than the mean, right? So we should expect the standard deviation or the z-score to be positive. Now, if we do this, we're just going to get 1. Okay, so the difference between 84 and 72 is just 12. So 12 over 12 is 1. So what's the probability that the probability that the z-score is greater than 1, which is what we're looking for, is equal to the probability that the z-score is less than negative 1, just using the symmetry of the table. So now we're going to look up negative 1 in order to get this probability. So we get 0.1587. All right, now the next one we're looking for the probability that the random variable is between a couple of values. So let's just first of all just convert those values to z-scores. 66 minus 72, which is the mean, divided by 12, which is the standard deviation, gives us a z-score of minus 0.5. Negative, that makes sense because it's below the mean. 78 minus 72 over 12, that's going to give us a z-score for 78. And we expect it to be positive, which it is, and it's positive 0.5. All right. So now we're looking for the probability that the z-score is between those two values. So I'm going to take the upper value, the probability that z is less than 0.5, and subtract the probability that z is less than negative 0.5. Okay, so I just need to look up those values. And so the first probability is 0.6915. And the other probability is 0.3084. And I take the difference of those two, and I get 0.3831. Okay? So that's the probability that our random variable is between 66 and 78. All right, now this next one is a kind of a reverse lookup problem. So we're looking for the probability that z is less than some value, and that probability is given to be 0.8686. All right, so just go into the table and look for that probability, 0.8686, and find the corresponding z-score, 1.12. That's what I get when I look it up. Okay, so now I have to convert that z-score back to the value of the random variable. So I'm looking for I want the value of the random variable to be 1.12 standard deviations above the mean. So I kind of think that you could set up the equation and solve it algebraically, but essentially we're taking the mean 72 and adding 1.12 standard deviations, right? So and the standard deviation is 12. Okay. So that's gonna give you the value that you want, 85.44. Okay, so the probability that the random variable is less than 85.44 is 86.86%. Okay. All right, so that takes care of that. The next section is just application problems, which are essentially the same as these problems we've just been doing in these last two examples. It's just that now we have words, we have some context around it. We have word problems, and so there's some context to it. So I will meet you in the next example.